All right, so once you have the Lewis structure, that is only the first step to thinking about what this molecule really looks like and behaves like in real life. After you have the Lewis structure, the next thing you need to know is what kind of shape it has. And so you can figure this out through VSEPR, right? Valence shell electron pair repulsion, right? And this will give you the shape of the molecule. And so what VSEPR depends on is how many things are around your atom. So that includes other atoms or lone pairs. And then how many of those other things are lone pairs versus atoms. So let's take a look at some structures. So we see here is the Lewis structure for carbon dioxide, right? So this central carbon is what we're concerned about. It has two things around it, right? It has two atoms around it. So we find two atoms and it has no lone pairs. This is a linear structure with a 180-degree bond angle. So that should be pretty simple. Next up, we have BH3. And so here we have a central boron with three things around it, right? Three atoms, no lone pairs. So we find three things, no lone pairs. This is a trigonal planar structure. And so this bond angle is 120 degrees. Another example, we have NH3. Right, so this nitrogen has three atoms around it and one lone pair. So it has a total of four things. So we want to go to four things, one lone pair. This is going to be trigonal pyramidal. So we did not draw this in the correct shape. We need to draw this in the correct shape. So trigonal pyramidal, it's a derivative of tetrahedral shape. So we can draw nitrogen, hydrogen going like this. We can draw a wedge to indicate the hydrogen is going out of the board. A dashes, so the hydrogen is going into the back of the board. And then a lone pair, right? And so that's the shape of our trigonal pyramidal. Remember, these bond angles are actually 109.5, but the lone pair repels more than a bond. So this bond angle is less than 109.5 degrees. So you want to really get good with Lewis structures and VSEPR.